As force, the external cause which changes or tends to change the state of motion an object or changes or tends to change the shape and size of the object is called force. A force can be a push or a pull. It is not something you can see or touch but can see it in action. Forces can be measured using a device called a force meter. The unit of force is called the Newton. It is represented by the symbol N. A force of 2N is smaller than 7N. A force usually results from an interaction. The interaction can be a physical one or a non-physical one. Forces resulting from physical interaction are called contact forces and examples include frictional tension, air resistance, and spring force. A force resulting from non-physical interaction is called action at a distance force and examples include gravitational, electrical, or magnetic force. Force is a vector quantity, so it has a magnitude and direction. The SI unit of force is the Newton N. Measuring forces. How is the force measured? Force meters contain a spring connected to a metal hook. The spring stretches when a force is applied to the hook. The bigger the force applied, the longer the spring stretches and the bigger the reading. A force can have the following effects on objects. I. Change the state of motion. 2. Make a moving object go faster. 3. Change the direction of a moving object. 4. Change the shape or size of an object. Balanced forces. Balanced forces are two forces acting in opposite directions on an object and equal in size. Anytime there is a balanced force on an object, the object stays still or continues to move at the same speed and in the same direction. It is important to note that an object can be in motion even if there are no forces acting on it. Balanced forces can be demonstrated in hanging, floating, and standing/sitting objects. Hanging objects. Take a look at this hanging glass bulb shade. The weight of the bulb shade pulls down and the tension in the cable pulls up. The forces pulling down and pulling up can be said to be in balance. Floating objects. Log in the water. Take a look at this log floating in a pool of water. It is floating because the weight of the log is balanced by the upthrust from the water. If more weight is tied to the log, the force pulling it down may be more and will cause it to sink. Standing/sitting on a surface. Reaction force. Consider a metal block resting on a surface of a table. Its weight is balanced by the reaction force from the surface. The surface pushes up against the metal block, balancing out the weight, force, of the metal block. Unbalanced force. When two or more forces acting on an object, then the resultant force is not zero, acceleration is not zero. Unbalanced forces. Unlike balanced forces, we say unbalanced forces when two forces acting on an object are not equal in size. Unbalanced forces can cause still object to move, moving object to speed up or slow down, moving object to change direction. Unbalanced forces make the wagon in the diagram speed up. Notice that because there is a bigger force and a smaller force involved, the direction of the wagon will be determined by the bigger force. The wagon is moving as a result of unbalanced forces. Resultant forces. To understand resultant forces better, let us see these two scenarios. Time a stationary object stays still, its resultant force is zero. As soon as force is applied, acceleration begins. The speed of the acceleration will depend on the force applied and the mass of the object. In a similar way, each time an object in motion, in a constant speed and same direction, stays in motion, its resultant force is zero too. As soon as a force is applied, it can make it stop, change direction, move slower or move faster. The resulting effect will depend on the force applied and the mass of the object. It is worth noting that an object may have several different forces acting on it. See the example in the illustration below. Resultant force. All these different forces F1, F2, F3 can be added up to know the resultant force, F4. The resultant force is the single force that has the same effect on the object as all the individual forces acting together. If different forces are acting in different directions, a resultant force can be determined as well. See the illustration below. Resultant force opposite notes. If the resultant force acting on a stationary object is zero, the object will remain stationary. If the resultant force acting on a moving object is zero, the object will carry on moving at the same speed in the same direction, i.e. at constant velocity.